So for part 2, it says, now that you have done 4 examples, you must determine the value of b squared minus 4ac, which is called the discriminant, which we kind of already done, but they just want you to actually show your substitution here and get your value. So we have the same equations, which we had 1 to 4 before. It's now called a to d here. So let's go ahead and do that. We'll show our substitution and then the value that we have. So here's a. We have b squared. B is positive 5 minus 4 times a. A is 12. C is negative 2. And when we simplify, it gives us 121. I'm going to go ahead and do b. For b, I've got b as 6, a as 3, and c as 1. When I simplify, that gives 24. Let's attempt c. See, here we have b as negative 6, a is 1, and c is 9. When we simplify, that gives us 0. Okay, also this is squared. Okay, so that gives us c. Now, you can pause the video and try out d. I'm going to go straight ahead and do the answer. So when we substitute, b is 4, a is 2, c is 10. That gives us negative 64. So these are our answers. Now part 2 had a question 1 and a question 2. Let's look at question 2. It says hence, and we know that in maths, whenever a question says hence, it means use your previous answer. Hence, determine the connection between the discriminant and the nature of roots of each equation in the table below. So we've got this table, and we need to fill in our discriminants according to the type of discriminant that we have. So we've got 4 types. We first have the discriminant being greater than 0 and a perfect square. And if we go up to the previous table, the perfect square was actually the first one where we had 121. So the equation that had the discriminant that was a perfect square was actually equation A, and it was 121. So we can fill in that information. Here we can say that it was equation A and it was 121. Now, according to that discriminant value, we need to answer these questions. Are the roots equal or unequal? And here's the thing. The roots that we had were unequal. Sorry, actually we should write down unequal. So those roots were unequal. They were rational. Remember, those values were 2 over 3 and negative 1 over 4. So they were rational, and the roots were real. They existed. Now we're now looking for the discriminant that is not a perfect square. If we go up here, the value that's not a perfect square is 24. So that is b, where b was 24. And according to this, we can actually scroll all the way up to where we had the roots for b, which was equation 2. And we can see that our roots were different. They also were not fractions. Essentially, it's the same information that we have here from those subsequent questions, but we're now filling it in this table. So the roots were unequal. They were irrational. And they were real. They did exist. Now we're talking about the part where the discriminant is equal to 0. And that happens to be C, where we had 0. If we look at the type of roots that we have, if we scroll back up to that question, we notice that we had the same answer as x, meaning that the roots are equal. They were rational and they were real. And the last part with the discriminant is less than 0. That is D, where we had negative 64. If we scroll back up to part 1, and we saw that there was no solution. So are the roots equal or unequal? That is not applicable since there are no roots. They are neither rational nor irrational, but they are non-real, so they do not exist.